Suppose we have to determine Young modulus of a material given in the form of a wire. Now this is Searle's apparatus. Now here this is reference wire. Wire A is reference wire, and wire B is the material for which this is the experimental wire for which we have to find out the Young modulus of elasticity. Both the wires are having same size, that is diameter and length are same. Now there are two rectangular blocks. Say this is block C and this is block D. These two are suspended from A and B, and at the end of this rectangular blocks there are hangers to put weight on this rectangular block. Now there is a wooden board. One edge of this wooden board is hinged in the rectangular block C, and the other edge is supported at the micrometer screw. This is the tip of the micrometer screw M. Now spirit level is kept at the center of this wooden box to see whether this wooden board is horizontal or not. Now dead loads are put on both the hangers. Dead load means just the load which doesn't produce any extension, but it keeps the wire tight. Now we will increase load on this experimental wire at a step of say half kg. What happens as the extension takes place for this wire B, this wooden board will not remain horizontal and will shift from its horizontal position. We have to adjust this micrometer screw to keep it horizontal, and whether it is horizontal or not we can see it from the spirit level. That is, when the air bubble of this spirit level is at the center, we say that the board is horizontal. So suppose load is increased at a step of half kg up to 5 kg. So 10 observations are made, and at each steps we have to keep the board horizontal and adjust the micrometer screw accordingly, and the reading of micrometer screws are noted. Similarly, now we will see that is contraction in length when the loads are decreased. So from 5 kg to 4.5 kg, half kg weights are now decreased from this experimental wire. So we have to adjust the micrometer screw again to keep the board horizontal. Now this is the observation table that we have noted. This is number of observation 1, 2, 3, 4. This is the load increase. Initially say dead load is considered as 0, then half kg, 1 kg, 1.5 kg. So loads are increased at a step of half kg. So the micrometer screw noted. This is reading of M. M means micrometer screw. Initially when both the wires were there, the reading of the micrometer screw was x1, then it is x2, then when the load was 1 kg, then the micrometer screw is x3, x4 up to x10. Now the loads are decreased at a step of half kg. Say 5 kg, then this will be 4.5 kg, 4.5 kg. So then suppose the length is y9, so then again half kg load decreased, so it becomes 4 kg. Then the micrometer screw reading is suppose y8. Similarly, this is the reading of the micrometer screw when the loads are decreased. So the mean extension at the time when the load was increasing, so x1 is the initial reading, x2 is the reading when load is half kg, so x2 minus x1 is the mean extension. Similarly, when the load is 1 kg, the micrometer reading is x3, initial reading is x1, so x3 minus x1 is the mean extension. Similarly, this mean extension at each steps are calculated. Mean extension mean extension means that is increase in the length when load was increasing. Similarly, the same thing that is decrease in the length when load was decreasing, also calculated. Now mean extension is this increase in the length plus the decrease in the length divided by 2. So mean of this extension when the load was increased by half kg, when the load was decreased by half kg. So this mean of these two gives the Z1. Z1 means the what is the change in length when half kg load is increased or decreased. Okay, so Z1, Z2, Z3, these are calculated. Now we plot a graph putting the mean extension along y-axis. So this is the mean extension Z, and load along x-axis. This is weight. So half kg, 1 kg, 1.5 kg, like this. This will be along x-axis. This is the load. Now we find that this graph is a straight line as long as the load are within the elastic limit. Now, so therefore Young modulus is load mg divided by the area pi r square by change in length to the original length, but here from this graph we find that is change in length, that is mean extension to the original length, this change in length, and this is the load mg. So tan theta is, from the graph we find that tan theta is L by mg. So we conclude that Young modulus is equal to L by pi r square into 1 by tan theta. So L is original length of the wire, r is radius of this wire, tan theta is this angle, gradient of this inclination of this straight line obtained after plotting mean extension versus load. So we can find out Young modulus of elasticity.